Hello class, we're going to do yet another construction that involves a triangle. This time we are going to create the medians of the triangle. We've done the perpendicular bisectors of the triangle. You should have already created the angle bisectors of a triangle, and today we're going to do the medians of the triangle. So let's go ahead and get a scalene triangle and create that on your screen. Alright, that's similar to the way we've done it before. The median of a triangle is a line segment that goes from a vertex to the midpoint of the opposite side. So let's go over here and find our midpoint tool. And I just want you to click on those line segments and have the computer locate that midpoint for you. And there it is. So now all we have to do is go over here and get the line segment tool and draw lines from the vertex to the midpoint, from the vertex to the midpoint, and from the vertex to the midpoint. And what you've created there are the medians of that triangle. Now notice, just like the others, the medians all are concurrent at a point inside the triangle. What's kind of neat about that point of concurrency is that no matter how you draw the triangle, whether it's isosceles, equilateral, right triangle, it just always, that median always ends up in, the point of concurrency always ends up inside the triangle. It will never be outside the triangle. Now some of the other points of concurrency, if you drag these vertices around, sometimes that point of concurrency actually ends up outside the triangle, which is kind of interesting, but for the medians it never does. Now I want you to Google the name of that point of concurrency. You'll Google the point of concurrency of the medians of a triangle. I want you to tell me what the name of that point of concurrency is, and when you find it out, you're going to click on your text tool, and then you're going to type the name of that point right here on your screen and label that for me. I want to know what that thing is called there. Now, so let's identify that intersection just a little bit better. Let's click on the intersection tool and then click on the two of the medians. Should be enough. It will create that intersection point. It defines that point for us. Alright, now there are some things that are kind of interesting about that point. So what I want us to do is I want us to measure some of these line segments we just created, because what you're going to find here is something that's kind of neat. So I want you to click on the line segment measure, which is distance or length. So you're going to go to the measuring tool, click distance or length. Now I want to measure this line segment from this point of concurrency to that vertex. So we're going to click the point of concurrency first, then click the vertex, and the measure of that line segment should show up right there. Alright, I'm going to move that so that I'll just probably put it right there on that line. Now I want to do the same exact thing with this line segment on this end. So I'm going to click the point of concurrency and the midpoint of that side, and you can see there is the actual distance of that line segment in units. Alright, let's do the same thing on the others. Start with the point of concurrency and then go to the midpoint, and looks like I got a perimeter there. I'm going to Control Z that off of there, and I want to move this to the correct line segment. I'm going to go get that measuring tool, and I'm going to click the middle point and the vertex, and then I'm going to move that to where it's right on top of that line. And I've got two more: point, vertex, and point, midpoint right there. So that one turned out a little off. I want to move that one over a little. It won't let me move it. There we go. All right, now I want you to look at these numbers. I want you to look at the numbers that fell on the exact same line, and I want you to see if you can determine a relationship between the two numbers. How is it related to this one? How is this number related to this one? And I want you to come up with some sort of conjecture or some sort of hypothesis about the length of this line segment compared to the length of the rest of the line segment. So you've got the long part and you've got a short part. A long part and a short part. How does the long part relate to the short part? And I want you to get your text tool and I want you to describe to me that relationship. The relationship between the long segment and the short segment is fill in the blank. I hope you didn't think I was going to fill that in for you. I want you to think about that. How does this line segment compare to this one when we create the medians of the triangle? So you're going to name that point. You're going to get with a neighbor maybe if you need to and talk about those line segments and see if you guys can come up with an idea of how they're related to each other. Then you're going to go to File, Export, Graphics View as Picture, and then you are going to paste that on that same Google Doc with your other two constructions. And as soon as you're done with that, we've got